Hey everyone, and welcome to this explainer. Today, we're looking at something absolutely massive in scale. We're going to unpack the incredible, high-stakes mechanics of India's weather systems. I want you to think of the Indian subcontinent not just as a piece of land, but as a gigantic, highly complex engine. It's literally an engine that powers the lives of over 1 billion people, dictates the entire economy, and, well, when it's pushed to its absolute limits, creates some of the most awe-inspiring and terrifying natural phenomenon on Earth.
So here is our roadmap for today. Number 1, weather versus climate. 2, diverse climate zones. 3, the 5 climate drivers. 4, the monsoon engine. And finally, 5, extreme disasters.
Okay, let's dive right into this. Section 1, weather versus climate. People use these two terms interchangeably all the time, but they actually represent completely different scales of time. First up is weather. Weather is the immediate, short-term condition you experience the second you look outside your window. It's that hour-by-hour, day-by-day reality. It might be a rainy morning that totally randomly turns into a bright, sunny afternoon. It's highly localized, and it constantly changes. So when you grab an umbrella before leaving the house, you're reacting to the weather.
Climate, on the flip side, is the big picture. It's the long-term, stable, predictable pattern of weather that an area experiences over a really long period of time. We're usually talking about chunks of 3 decades or more here. So while weather dictates what jacket you wear today, climate dictates what crops a farmer decides to plant for the entire year.
And when these long-term climate patterns repeat reliably year in and year out, they create our seasons. Now, while a lot of the world talks about 4 seasons, traditionally, in many parts of India, the year is actually divided into 6 distinct seasons, known as ritus. We've got Vasanta for spring, Grishma for summer, Varsha for the rainy season, Sharat for autumn, Hemanta for pre-winter, and Shishir for winter. Our daily lives, our biggest festivals, and our agriculture are entirely synced up to this exact rhythm.
Which brings us to Section 2, diverse climate zones.
Because India's geography is just so vast, it's essentially a patchwork of wildly different environments. Notice the stark visual contrast here. In the north, we have the huge Himalayan mountains, boasting an alpine climate. We're talking freezing, snowy winters, and really cool summers. Yet, travel over to the west, and you hit the Thar Desert. That is a completely arid climate featuring scorching hot days, cool nights, and virtually zero rainfall. These two total extremes exist within the exact same country.
All right, moving on to Section 3, the 5 climate drivers.
So, how can one single landmass support such opposite extremes? It's because India's climate is basically a massive mechanical system controlled by 5 specific dials, or drivers, and they are latitude, altitude, proximity to the sea, winds, and topography. Let's look at how each of these dials is actually tuned. Dial number 1 is latitude, meaning your distance from the equator. The places near the equator get hit with nearly perpendicular, highly concentrated solar radiation, which makes them much hotter. But as you move away towards the poles, the sun's rays hit at this oblique angle, spreading all that energy over a wider area and passing through more atmosphere, which dissipates the heat. This is exactly why Kanyakumari, way down south near the equator, stays warm all year round, while a northern city like Srinagar is dramatically cooler.
Next up, we have altitude. As you travel higher up into places like Darjeeling or Udagamandalam, which you probably know better as Ooty, the temperature drops. But why? Well, 2 reasons. First, atmospheric pressure and air density decrease as you go up, and thinner air just doesn't hold heat very well. Second, the sun actually heats the surface of the Earth, which then radiates that heat back up into the air, so the further you are from that surface heat, the cooler you are. That's exactly why hill stations are the ultimate escape from those sweltering summer plains. The third dial is proximity to the sea, which acts as nature's ultimate thermostat. The sea absorbs and loses heat much, much slower than land does. Because of this, coastal cities like Mumbai enjoy a highly moderated climate, with a super narrow annual temperature range of just about 14 degrees Celsius. But then look at inland Nagpur. Without the ocean's moderating breeze, Nagpur suffers some severe extremes. It pushes way up to 44 degrees in the summer and drops down to 10 degrees in the winter. That's a massive 34-degree temperature swing.
Dials 4 and 5 are winds and topography. The physical shape of the land, mountains, valleys, slopes, creates totally unique local microclimates, like how the Himalayas physically block freezing winds from Central Asia. But topography isn't just natural anymore. Actually, scratch that. Look at the dense concrete cities here. Large buildings and a lack of vegetation trap heat, artificially creating what we call urban heat islands.
It literally makes cities significantly hotter than the surrounding rural areas.
Next up, Section 4, the monsoon engine.
Now, what's really interesting about this is what happens when all 5 of these dials interact on a massive scale. You get the ultimate result of this geographic engine, the monsoons. The sheer physics of it is just fascinating. Check out the summer setup. The fundamental rule of wind is that it flows from high to low pressure. So as summer hits, the giant Asian landmass heats up way faster than the ocean. Hot air rises, creating a powerful low-pressure vacuum over the land. This massive vacuum physically sucks in cooler, high-pressure winds from over the Indian Ocean. And because these winds travel over thousands of miles of water, they arrive completely loaded with moisture, dumping life-giving heavy rains all across the subcontinent. This is the famous southwest monsoon.
But hey, engines have cycles, right? And as winter approaches, the entire system slams right into reverse. Now, the landmass cools down much faster than the ocean. The land becomes a high-pressure zone, and the relatively warmer ocean becomes the low-pressure zone. The winds totally flip. They now blow from the land out towards the sea. Since they originate over dry land, these northeast monsoon winds are super dry, bringing cool, clear conditions to most of Asia, save for a few areas in the south that manage to catch some moisture coming off the Bay of Bengal.
And we absolutely cannot understate the sheer volume of water this engine moves around. To give you a real sense of the extremes here, get this. Mausam, located in Meghalaya, doesn't just get heavy rain. It receives the highest average annual rainfall in the entire world, about 11,000 millimeters. To put that into perspective, that is an unbelievable, staggering concentration of atmospheric moisture funneled into one specific tiny geographical location.
So, the monsoon is this predictable, life-sustaining engine. But nature is rarely tame. What happens when the atmospheric pressure drops way too fast? When the water overflows? When the dials on this engine are pushed completely into the red?
That brings us to Section 5, extreme weather and disasters.
When this powerful climate engine overflows, the consequences are honestly catastrophic. Let's look at 2 specific outcomes. First up are cyclones, which are essentially the low-pressure mechanics we just learned about, spun violently out of control. It happens in a pretty predictable sequence. First, an intensely low atmospheric pressure center forms over the sea. Second, surrounding air violently rushes into this void, bringing massive amounts of moisture with it. Third, this moisture forms clouds that begin to rotate inwards, entirely due to the Earth's rotation. And finally, wind speeds accelerate to highly destructive levels, creating a massive spiraling cyclone. To truly understand the scale of this, look at this satellite capture of Cyclone Fani. This isn't just a storm, it is a massive, self-sustaining atmospheric beast. You can clearly see the distinct, cloudless eye of the cyclone right there in the center of that depression, surrounded by hundreds of miles of violently rotating clouds. When a system this powerful hits the Indian coastline, it rips up trees, completely destroys power grids, and forces mass evacuations. It's serious business.
The other major extreme outcome is flooding. Heavy monsoon runoffs can quickly overwhelm rivers, sure, but in the Himalayan regions, it gets even more volatile with sudden glacial bursts. If a glacial lake overflows, a massive wall of water breaks right through the rock barriers. This really brings home the tragic human reality of these systems. Back in 2013, Uttarakhand experienced a sudden glacial burst followed by continuous, relentless, heavy rain. Entire villages and roads were literally washed away. The areas around the secret Kedarnath temple were destroyed, and tragically, altogether, about 6,000 people lost their lives. Which brings us to a bit of a reality check. At the very beginning of this explainer, we defined climate as the long-term, stable, predictable pattern of weather. But here's the thing, it is no longer entirely stable. Scientists are clearly recording that human actions are now artificially altering the very engine dials we've been discussing today. And because of this, these extreme disasters we just talked about are becoming much more frequent and way more unpredictable. So the crucial takeaway here is this. We are no longer just passive passengers experiencing India's weather. By changing the atmosphere, warming the oceans, and fundamentally altering the topography, we are actively tinkering with the engine itself. As human actions continue to shift these incredibly delicate dials, how will India's powerful climate engine react next? It's a huge question that affects over 1 billion lives, and one we must absolutely all seek to understand. Thanks so much for joining me on this explainer, and remember, keep looking up at the skies.